This is a video tutorial for learning purposes only. I'll be explaining an exclusive OR gate symbol and its function. Right here we have an electric circuit emulating an Xor gate. A 5-volt battery, 1 k ohm resistor, a switch A and a switch B. This dotted line means that switch A is there's a mechanical interlock between this switch and this switch right here. But this is all switch A. So when you push on A, this part will open. This is switch B with the mechanical interlock in between. So when you push on B, this will open, this part will close. Right here we have a logic gate symbol for an exclusive OR gate. This is for the A input, this is for the B input. Y is the output. This is a truth table. I'll be using this illustration to help describe what's happening right here, this truth table. When you don't press A, right here, and you don't press B, the output will be 0 right here. No logic flow through, none. When you don't press A right here and you do press B, logic flow goes through right here. When you do press A and you don't press B, logic flow flows through, a logical 1. When you do press A and you do press B, logic flow will not go through. This right here is a 4070 quad exclusive OR gate IC microchip. Let's give you a closer view of that chip before we go any further. As you can see, the positive goes on pin 14, the ground goes on pin 7. The A would be on pin 1, the B would be on pin 2, and the output would be on pin 3. We have this chip is right in here. Let's turn this on so we can show you exactly how it works. So, when you press A, it works. When you only press B, it works. But when you press both, it will not work. And that's how it works. Okay. A or B. So it's either exclusively A or exclusively B, but not both. Okay. What we have here is PLC programming. This is the hard part. Now, we have a normally open push button for push button 1. This is an examine if closed instruction. Examine if open instruction. Since it's open, this is true. This is true. This right here is an examine if closed instruction, so this is false right now. Right here on push button 2, we have a normally open push button. This is an examine if open instruction. This would be true. Now, this is an examine if closed instruction. This is actually false right now. Another way you can help yourself to understand this is to look at the symbol and ask yourself a question. In this one you would ask yourself, is the contact closed? No, that's a false, because this is a normally open push button right here. So this is false. Same thing right here. You'll ask yourself, is the contact open? Right here, yes, it is true, because you have a normally open push button. That's why this would be true. Same thing right here. Is the contact open? It's a normally open push button. This is true. This is an examine if closed. You ask yourself, is the contact closed? False. Because this is a normally open push button. When you do push on the button, this will become true, and this will become false. So it allows logic continuity to flow through here, through this true, all the way to the light, turning on the light. You release the button, this goes back to false. This goes back to true. You push on push button 1. This becomes true, and this will become false. That's if you push the push button number 2. So it allows logic continuity to flow through this route, turning on the light. When you let go of the button, this will go back to true. This will go back to false. And that's how an exclusive OR gate circuit works.